Okay, so bond valuation is something that I feel we all kind of struggle with because it's something that we don't spend enough time in the classroom on. And this video seeks to show you how do you master a bond valuation question that you're extremely likely to see on your exam, assessments, or assignments. So taking the time to understand the two approaches we could take to solve bond valuation problems will be crucial to your success. And that's exactly what we're going to do in this video. So let's give it a shot. So if we consider the problem that we have in front of us right now, we are looking at the following. So bond X is a 10-year semi-annual coupon bond. All right, that's important. Which was issued at par 5 years ago. Good to know. The yield to maturity 5 years ago was 6%. How much does bond X worth currently when the yield to maturity is 8% now? And note that the face value is $1,000. So we for sure have a lot of information here, but how do we try to segment this information into different buckets to be able to solve this question effectively? Now, as you can see on the screen, I have two approaches, the one in which we use our financial calculator, and then we have another approach, the one in which we use our bond valuation formula. Now, as you can see, there are several different little concepts that you need to understand, and we're going to jump straight into them and really make sense of them in real time. So, before we begin, let's try to identify the different elements of this question that are important for us and give them a rationale. So, we know here, which is really important, is that we have a 10-year bond. This could be crucial. And then we know that it's a semi-annual bond, okay? This is extremely crucial as well. What does this mean for us? A semi-annual coupon bond essentially states that you're going to be making 2 payments per year. All right? Not 1, but 2 payments per year. And obviously, as you have more years, as more payments will be made. And that's extremely important to consider while we fabricate our formula and while we go through our financial calculator. Now, another really important part to be discussed here is that at par, this was a bond that was issued at par, okay? And this essentially means that, I'll zoom in for y'all. This essentially means that YTM was equal to the coupon rate, okay? So the yield to market 5 years ago was equal to the coupon rate 5 years ago. This is going to be crucial for us when we want to calculate our coupon payments, okay? And we also state right here that our bond was issued 5 years ago. But remember, at the very beginning, we said that this was a 10-year bond. So what does this mean for us? And let me give you a quick visual representation such that you understand how we should apply this to our question. So if this was issued 5 years ago, all right? If this was issued 5 years ago, this would mean that at T0, right? If we look at the whole lifespan of our bond from year 0 to year 10, because it's a 10-year bond, we know that today, all right? Today, we know that we're at T5 because it was clearly stated 5 years ago, all right? Therefore, we don't need to consider this part of the past. It's not important for us. We just want to evaluate our bond from today to the very end of our bond. Therefore, what I'm trying to say is that from T5 to T10, we have 5 years remaining. Okay? This is the only simple, curveball they're throwing at us, all right? So essentially, this just means that the lifespan of the bond, when we're going to plug this in within our formula or our calculator, it just means that we're looking at 5 years from today. We're not going to be looking at 10 years, all right? Really important to consider. Now, once that we know that, and I know I'm going slow, but I just want to make it super simple for you such that you have all the different points of references that you will need on your exam. And now we tell you that the yield to maturity 5 years ago, okay, was 6%. So the yield to maturity 5 years ago was 6%. Therefore, what this means for us, if you remember, we said that if something is issued at par, that means that the yield to market is equal to the coupon rate. Therefore, this means that our coupon rate 5 years ago was 6%. All right, and why does this matter for us? We look at the coupon rate to find what are the payments that the company, or whatever the case may be, the issuer of the bond will be making to bondholders. Let me say this one more time. The coupon rate is extremely relevant for us because it's an indicator of what will be the coupon payments made to the bondholders, all right? And in order to find said payments, which we'll look a little bit further afterwards, all you have to do is take your coupon rate multiplied by the face value, all right? And then you're going to divide that by the number of payments made per year. And that's how you find your coupon payments, all right? Just a quick indicator for you. Now, if we go through the question a little bit more, we tell you, well, how much does bond X is worth currently, okay? And this is just another way to say, what is it worth today? What is coupon X worth today? Now, if you remember with my little ghetto illustration, we were saying that we're looking at this from T5 moving forward, okay? So we're here, we're today. We want to know what's the present value of the bond because we want to know what is it worth today, right? So today, it's extremely important. And that's going to make sense for you when you apply this logic to your calculator and when you apply this logic to our formula, all right? So with that said, now we have a lot of information. And the last piece of information that we need is the following. That the yield to market is 8%, okay? The yield to market today, so our KB, our interest rate, if you will, our discount rate is equal to 8%. That's what it means, okay? Yield to maturity is 8% now. That is our yield to market that we're going to utilize. That's our IY, that's our interest rate, that's all the good stuff, okay? And then finally, we need to assume that if nothing is said, that the face value is equal to $1,000. In this case, they tell you the face value is $1,000. So now that we have all this really cool information, we're able to go through our two approaches. The first one being the financial calculator, and the second one being using a formula. Now, one is not better than the other. I'm just looking at these two options to make sure that you're comfortable and empowered to break down these questions in the way that works for you. So let's begin with the financial calculator. How do we identify these elements we looked at and place them in the right input and then calculate the value we need, which is the answer, okay? So with that said, we know that the present value is what we're seeking. The present value is what we're looking for. So how much is the bond worth today? Right, that's exactly what we're looking for. How much is the bond worth today, i.e. we're looking at the present value. Now, the face value, okay, the future value of the bond, essentially what the company or the bond issuer will give to the bondholders at the end is equal to the future value. Essentially, this is just a very long way to tell you that FV will pretty much always be $1,000. And to make this simple for you, I've taken the liberty to show you my financial calculator. So as you can see right here, although it's a little bit blurred, future value is going to be 1,000, okay? Future value is going to be 1,000. Now, N is really interesting, okay? So we know, if we go back to our little ghetto illustration, we know that we have 5 years remaining, okay? But what I want you to remember here is that we have 5 years remaining, but we know we are making payments twice per year, okay? Therefore, if we have 5 years remaining and we are making payments twice per year, how many total payments are being made? That's the question you need to ask yourself, and that's a really good sense check to have when you do your exams. In this case, we know that we have 5 years remaining. We're doing 2 payments per year. Therefore, we have 10 total payments, and that's going to be our N, the amount of total payments we're making. How many times are we paying our bondholders, okay? So in this case, when we look at our N, we have to do 5 years, okay? So 5 years remaining, multiplied by payments per year, okay? So essentially, we're looking at how many periods we have, and this is going to be essentially 5 times 2, which is going to give us 10 as our N. Now, for our payments, now we go back to the same idea, okay? To find our payments, we said that the coupon rate is extremely important. Now, because we know that YTM is equal to the coupon rate, we know that that's 6%, right? So the first thing we want to look at is 6%, our coupon rate, multiplied by the face value, which is $1,000, and we're going to divide that by the number of payments per year. Okay. And that's going to be 0.06, okay, times 1,000 divided by 2. And that's going to give us 30. So our payments are equal to 30. Now let me say this one more time, and I'm going to risk being boring and annoying. All right. So if we want to find our payments, we need 3 elements. The first one being the future value. The second one being the coupon rate. And then the third one being the amount of payments we are making per year. Once you have these 3 elements, you could multiply, okay, your face value by the coupon rate. And then divide that value by the number of payments being done per year, okay? So what we did here is $1,000 times 6%, our coupon rate, divided by the number of payments done per year. And that gave us our payment that we're going to plug in our calculator right here. All right, payment. Now, if you remember, N is this right here. So that was our 10 that we've discussed. And then payments right here will be 30. Okay. Now for IY, okay, so our interest rate, our KB, if you will, this is really simple. What you need to do is you need to apply the same type of thought process you had. We know, if we look at our question, that the yield to maturity is 8% now. However, we have payments that are being done every 6 months, i.e. twice per year. So to find what's the actual IY that you're going to place within your calculator, all that you have to do is take whatever amount they give you in the problem and divide that by the number of payments done per year. So in this case, what we have is 8%, which is our YTM now, divided by the number of payments done per year. And that's going to give us, you guessed it, 8% divided by 2, i.e. 4%. Amazing. Now we have everything that we need. And what I'm going to give you now is a trick. When you do these questions, to make this simple for you and to plug this in within your calculator, I definitely recommend that for your PY and your CY, so the payments per year and the compounding amount per year, you set them to 1. Okay? This is kind of a illogical, not illogical, but it's kind of a, niche type of trick that you could use that's going to make this really simple for you. Okay? So in order to do so, what you're going to do is you're going to do, first of all, you're going to open your calculator, and then you're going to do second IY, and you're going to find your PY, which you're going to set to 1, and then that's automatically going to set your CY to 1 as well. And once you've done that, all that you have to do is press clear, clear. And then you could plug in all the different elements we've discussed. Okay? That's how you do this within your calculator. Now, once you've plugged all this good stuff within your calculator, you're going to find your answer. And although I'm taking a lot of time, you can skip this part, but I'm going to do it with you. And then we're going to move on to our formula, which is similar as well. So we said that we know our future value is equal to $1,000. So what we're going to do is we're going to plug in future value at 1,000. Once you've done that, we know that our N is equal to 10. So you're going to do 10, then you're going to plug in N. We know that our payment is equal to 30. So you're going to plug in 30, and then you're going to go right here and press payment. Okay. We also know that our interest rate, our IY or our KB, is equal to 4. So you're going to plug in 4, and then you're going to press IY. All right. And then we know that we have our N, although I'm pretty sure we already did it. I'm going to do it again for the sake of being, good. And then what you're going to do is you're going to do the following. Because we're seeking our present value, we want to know what our bond is worth today. You're going to press compute, Then you're going to press present value. And that's going to give you the following amount. Now, this is reversed for you, but for me, it's 918.89. Okay? And that's the answer here. 918.89. And if you want, as you can see, the answer is right there. Now, if you thought that this was simple enough and that works for you, you're able to remember this, you want to put this within your cheat sheet or something of that nature, go for it. Now I'm going to show you how to do it with our bond valuation formula. And simple steps, the same idea. We don't need to dive into it too much, but I'm going to show you how do we plug this in within our formula and how do we go about this fairly quickly, okay? And kind of show you the little tricks here. And we're gonna refer to our following data here a lot, just to make this simple, okay? So if we look at our bond valuation formula, I'm gonna zoom out just a little bit, we have the following function, okay? Present value is equal to C divided by KB times this big little factor plus this other factor. Now, what I did to make this simple for you is I have highlighted several different inputs that you need to understand, and then you're going to be able to reference the question like that to find what you need to put in it. So, obviously, C stands for our coupon payments, okay? And then KB is going to stand for our yield to market, essentially YTM. And you could also call this, if you want, IY, okay? All the same ideas are being applied. Now, the next thing you want to know, and I think is the most important factor here, is that N, once again, is going to be the number of payments being made. And this goes back to our same idea here. Our N will be the same value that we have here, 5 times 2, so 10. That's going to be the N that we're going to apply to this question, all right? Now with that, we could use our calculator. We could use our formula and plug everything in to find what that would look like. And I'm going to do that with you. We're going to do it hand in hand. And you're going to be able to see how we do this and how we get the correct answer. Okay? Now we know the answer we're looking for is equal to 918 approximately. Now we're just going to plug everything in and we're going to see what it's up. One thing I didn't mention, although it's fairly obvious, F is equal to face value. Okay? So present value, 0, is equal to our coupon payment. Remember, our coupon payment is equal to the following. It's equal to 30. All right. We're going to put that over our yield to market. Now remember, our yield to market has to be divided by 2. It's the same value we've applied right here. Okay. So we're going to divide that by 0.04. Okay. Then we're going to multiply that value by 1 minus 1 over 1 plus KB, so 1.04 to the power of 10. All right, and then we're going to do that plus the face value, which we know is 1,000, over 1.04 to the power of 10. Now that's how you plug in all the different information we've discussed. Now, as you can see, I want to make this extremely clear. All of the values we have are the same ones we looked at towards our financial calculator. So the same thought process can be applied, okay? Now, with that being said, what we're going to do is we're going to calculate the values we need, right? Now it's simple math. So 30 divided by 0.04 is equal to 750, okay? Essentially, you do 30 divided by 0.04. We know that 0.04 goes into 1, if I'm not mistaken, 25 times. So you do 25 times 30. Then 1 minus the following. So we know that 1 over 1.04 gives us the following. So 1.04 to the power of 10, 1 divided by that, then 1 minus that will give us 0.032. So I'm sorry, I'm kind of making this quicker for us. So essentially, what we're trying to do right here is we're trying to find a value for every single bucket, right? So we have, we have bucket A, bucket B, then we have bucket C, Okay. So now the final part, what we're going to add is 1,000 divided by 1.04 to the power of 10. So 1.04 to the power of 10, 1,000 divided by that will give us 675.56. Then your present value is going to be equal to 750 times 0.32, 435. And that's going to give us 243.326 plus 675.56, such that the present value is equal to the following: 918.89 approximately. And just like that, I did this quickly, but just like that, and this is astonishing, you're able to get to the same answer, right? One really focused on using a formula. The other really focused on using your financial calculator. And with the different levels of comfort you have, maybe due to your own studying process, the type of person you are, you'll be able to leverage the things you need. And what I would recommend for you is to just plug this in within a formula sheet. Typically, you are allowed to have one on your exam. So why not use that to your advantage? I would definitely recommend that. And from there, you get to practice and choose what works best for you. Now, if you don't know already, you have a bunch of studying material and learning material available to you on my website, and also available to you on this YouTube channel, Ismahelps. You will find a bunch of different videos tailored and made for you, a student trying to understand and empower themselves to do the best I know you can on those exams, assessments, assignments. So with that being said, I hope I was able to help you out, and I really want to be able to really give you a hand in any different feature that I could. So if you have questions, ideas, concerns, send them to me, comment it down below. I'd be more than happy to help you succeed. So have a good one.